so last week we went through chapter 1. Okay, so it was kind of introduction about what is science, what is life science, why do we have to study biology, okay, and so on. Chapter 2 and chapter 3 is kind of makes you wonder, is this biology? Maybe not. It's basic general chemistry, but we need to know certain chemistry principles that to understand phenomenon of biology. Okay, that's why we have to go through a little bit of kind of boring stuff, right? But just keep with me, okay? Okay, so chemistry is building block. So we have to understand what is this materials that make up life. Okay, so in this chapter 2, the building block of all the material is the atom. Okay, it used to be, there is a cartoon called Atom. Okay, but it's an atom. Okay, so the atom is the fundamental unit of matter. Okay, then atom consists of 3 components. Okay, protons, neutrons, electrons. So this is hydrogen atom. This is helium atom. Okay, atom consists of a nucleus where the proton and neutrons locate, and then the electron goes around, okay, far away. An electron has negative charge, where the proton has positive charge. Neutron doesn't have any charge. Okay, so it's basic thing. Protons are positively charged, electrons are negatively charged, neutrons carry no charge. Okay, so next term is element. Okay, element is any substance that cannot be reduced to any simpler set of constituents substances through chemical means, whatever. Okay, so the other term that we have to know from the book is called isotope. Iso means something same. Okay, so isotope is defined as single element can exist in various forms called isotopes, depending on the number of neutrons, because they're same elements, but they have different numbers of neutron. Okay, so their weight, the molecular weight is different. Example is here. Okay, hydrogen, as we know, it has 1 proton and 1 electron. Okay, there are 2 isotopes of hydrogen. It has different name, deuterium or tritium. Okay, in deuterium, they have 1 more neutron in the nucleus. Okay, in tritium, they can have 2 more neutrons. Okay, they become heavier. Okay, so all this we call it isotopes because they're the same element, but they have different numbers of neutrons. Okay, so we call them isotopes. Okay, isotope doesn't mean much in biology, but if it is radioactive isotope, then it means something. Okay, in this case, tritium is radioactive. What do you mean by radioactive? Because this state is a little bit unstable. Okay, so they want to become stable. By doing so, they can irradiate some energy to outside. That's we call it radioactive. Like case in Japan. Okay, nuclear plant is based on who is. Yeah, who is it from nuclear? Right, probably you know much better than I do, right? But so radioisotope is important in biology because if you look at the book, it doesn't have it. If you have 5th edition book, do you have mostly 4th edition? How many of you have 5th edition? Okay, never mind then. Why this radioactive isotope is important? Because biologically we can use those radioactive isotopes. Tritium we can use sometimes, okay? So if this tritium is trying to become a stable element, they irradiate some radioactivity. We can detect those activity, okay? Tritium is very weak, but if it is like carbon-14 or P32, those are different radioactive isotopes, okay? For example, in order to treat cancer or like thyroid cancer, you can eat some of the radioactive which can deposit into cancer cell, and they can irradiate energy. They may kill some cancer cells. So radioactive isotope is important for biology. That's why you have to understand what is isotopes first. Okay, isotope is defined as same element has different number of what? Neutrons. Okay. Okay. So some of them are radioactive. They can emit energy. Okay. That's about it. Okay.
About 2,400 years ago, the Greek philosopher Plato believed that all matter is made up of 4 primary substances: earth, air, fire, and water. A near contemporary of his, Democritus, took the next step. He thought that these primary substances were made up of smaller units that were both invisible and indivisible. They could not be broken down further. He called these units atoms. The fundamental unit of matter is the atom. The 3 most important constituents of the atom are protons, neutrons, and electrons. Protons and neutrons exist in the atom's nucleus, while electrons move around the nucleus at some distance from it. Protons carry positive electrical charge, electrons are negatively charged, and neutrons have no charge. An element is any substance that cannot be reduced to any simpler set of constituent substances through chemical means. Each element is defined by the number of protons in its nucleus. The number of neutrons in an atom can vary. Thus, a single element can exist in various forms called isotopes, depending on the number of neutrons it possesses. The atomic number of an element is the number of protons in an atom of the element. The atomic weight, or mass number, of an atom is the sum of the number of protons and neutrons. Here, different isotopes of an element have the same atomic number, but different atomic weight. In an atom, the number of positively charged protons and the number of negatively charged electrons are equal. Thus, an atom has no net charge. However, an atom can gain or lose electrons and become charged. We term this an ion. An ion has its number of protons different from its number of electrons. If the electron number is larger than the proton number, it is negatively ionized. If the electron number is smaller than the proton number, it is positively ionized. The periodic table is a systematic classification of atoms according to the number of electrons that they contain. These electrons fill atomic shells. The rules for how these shells may be filled are responsible for the chemical properties of the atoms. The shells have strict occupancy restrictions. The innermost, or first shell, can contain at most 2 electrons. The second shell can contain 8 electrons, and the third shell can contain 8 electrons. So the first 3 shells can contain at most a total of 18 electrons.
Awake? It didn't fall you into sleep? Okay, that's good. All right, so we talked about isotope. Okay. And we did this one. Oops, where were you? Okay, so the key term that you have to remember was isotope, okay, defined as same element with different neutrons. Some of them can be radioactive, okay, which are important for life science, okay. And the video showed some element or atom can be ionized, become ion, okay, become charged. Okay, that's important for next part. So we'll go through chemical bond. Okay, this textbook will explain 3 types of chemical bond. 화학결합. Okay, chemical bond. There are 3 types. The first one I'll go through ionic bond, 이온결합, ionic bond. Okay. Second one I'll go through covalent bond, which we'll call it 공유결합 in Korean. Okay, covalent bond. The third one is called hydrogen bond. Okay, the textbook is a little bit, the order is a little bit switched. They will explain covalent bond first, but I'll go to ionic bond. So I compare this ionic bond as dating. Okay, male and female, positively charged, negatively charged, they are attracted to each other, and they're attracted to each other. You find your, girlfriend, boyfriend, you're dating, which is ionic bond. Okay, because they explained about what is ion. Either the atom can gain electron or lose electron. If it gains electron, what it is charged? It's negatively charged, right? If it lose electron, it will be positively charged. Okay? If it charged ions, they can have attraction to the opposite charge. Okay? So that's the bond between plus and minus is called ionic bond. Good example is sodium chloride. It's table salt. Okay? So sodium, okay, in this case, has 2 electrons in the first shell and 8 electrons in the second shell and only 1 electron in third shell. Okay? So what happens is it easily can lose this 1 electron. If it loses, it becomes positively charged, Na plus. Okay? Sodium ion. Okay? The opposite is true for chloride. Okay? Chloride has 2 electrons in the first shell and 8 the second shell. The third shell, if you have 8, is a full. Okay, it 1 minus. It has 7, so it wants to have 1 more. Okay, it could gain electron, so it become negatively charged. Chloride ion. So Na plus, Cl minus attracted to each other. They come close. That's the chemical, the ionic bond. Okay, okay. So you have boyfriend, girlfriend. They like each other, but the bond is not that strong. Okay? If you dissolve this salt into water, what happens? They become separated. Na plus, Cl minus. Okay? They are available. Okay? So this is chemical ionic bond. A little stronger than ionic bond is second bond is called covalent bond, 공유결합. Okay, so you date your girlfriend or boyfriend for a long time. Then what is next step? Decide to get married. Okay, what is the difference between dating and get married? What is it? What is the difference? You commit yourself. What else? You share a space. Okay, you live together, right? That's it. The share the electron is covalent bond. Okay, so you go through it. So what happened is, a good example is water molecule. Okay, H2O. So oxygen atom has 2 electrons in the first shell and 6 electrons in the second shell. So they want to have 2 more electrons to fill 8. Okay, that electron can come from a hydrogen atom. Each one give 1 electron. Okay, so they can share. How do you share? 2 hydrogen and 1 oxygen molecule form a water molecules or atom comes together and water molecule, then what happens is they can share, okay? They can share these electrons. It's like moving in and live together. It's marriage. So marriage is stronger than dating, okay? So covalent bond is a little stronger than ionic bond. Understand? Yep. But then there is, you married, okay? You're married. But there is a power game in husband and wife, okay? This power game is even, okay? Then they are happy. But if it is power game is shifted to one side, they are not happy, okay? So that's called polarity. Polarity means which atom has more electron, okay? So electronegativity difference, okay? One can be more negative than the other, okay? That was the case for water molecule. Think about water molecule going back. So oxygen had the other electrons, okay? Hydrogen didn't have it, okay? So what happened is, although they share the electrons, what happened is oxygen atom still has a little bit negative charge. Delta minus means small negative, okay? And then hydrogen atoms has slightly delta plus positive. So in other words, there is a power shift in husband and wife, okay? So what happened? They are polarized. We call it, the power is shifted to one side, okay? On the other hand, there is a different type of marriage. In this case, non-polar. They share the power equally. Okay, good example is methane gas. In this case, carbon. Carbon has 4 electrons outer shell. Okay, they can fill 4 more. Okay, so they can have covalent bond with 4 more hydrogen. But now, the power game is evenly distributed. Okay, so we call methane non-polar. In this case, it's non-polar. It's important characteristics of molecules. We'll go back in next chapter. All the molecules in our body is a little bit polarized. Okay, that will come, is very important. Okay, so what happens if you have this polar? So there is 2 different type of covalent bond. One is polar covalent bond. In other words, shifted to one side, or equally shared. It's non-polar covalent bond. Okay. So the third type of bond is called hydrogen bond. Okay. It has something to do with polar covalent bond. Go back. Okay. So what happened is water molecule. Water molecule is polar covalent bond, right? Delta plus and delta minus. What happened is, even though you're married, you become interested in someone else's wife or husband. It's a bad thing, but you know. So what happened? You have little dotted line between plus and minus. Okay? Plus and minus. Now this is hydrogen bond. Okay? Hydrogen bond is very weak. Right? Right? You're married, so you can do much about it. But this little hydrogen bond is very, very important to define the characteristics of water. Okay, even though this hydrogen bond is small, it can have lots of bonds, then that's important. Okay?
Atoms may join together to form molecules. The ties that held atoms together in molecules are called chemical bonds. There are several types of chemical bonds. One of the most important is called a covalent bond. A covalent bond is formed when 2 atoms share 1 or more pairs of electrons. 2 atoms of hydrogen have come together, and each shares its lone electron with the other. This gives both atoms a filled outer shell and stability. 2 atoms of hydrogen can link with 1 oxygen atom. In this case, two pairs of electrons are shared, one pair between each of the hydrogen atoms and the oxygen atom. When two or more atoms combine in this kind of covalent reaction, the result is a molecule, a compound of a defined number of atoms in a defined spatial relationship. In the example shown, the covalent bonds form the molecule H2O, water. Another example of a simple molecule formed by covalent bonding is methane, CH4. Not all covalent bonds are the same. Sometimes a molecule can take on polarity, or separation of electric charge. The bond is now called polar covalent. In a nonpolar covalent bond, like methane, all of the shared electrons are approximately equally attracted to carbon and hydrogen. In a molecule such as water, shown on the left, the oxygen atom has a greater power to attract the shared electrons and pull them toward the center of the oxygen atom. The measure of this pull is called electronegativity. The oxygen atom has more electronegativity than the two hydrogen atoms, so it tends to pull the shared electrons toward it. This creates a slightly negative charge at the oxygen side of the molecule and a slightly positive charge on the hydrogen side. The most extreme form of polarization in a chemical bond can be viewed as the donation of an electron by one atom to another. The resulting bond is called an ionic bond. Sodium has a single electron in its outer shell. Chlorine has 7, meaning it lacks only a single electron to complete its outer shell. When these two atoms come together, sodium loses the electron from its third shell to chlorine, becoming, in the process, a sodium ion with a net positive charge, because it now has more protons than electrons. The chlorine atom becomes a chlorine ion with a net negative charge, because now it has more electrons than protons. The sodium and chloride ions are now attracted to each other because they are oppositely charged. The result of this electrostatic attraction, involving many sodium and chloride ions, is a sodium chloride crystal, NaCl, better known as table salt. Hydrogen bonding results from an attraction between hydrogen on one molecule and an electron-hungry atom like oxygen or nitrogen on another. It is particularly strong in water between hydrogen on one molecule and oxygen on another, and is responsible for many important properties of water. Raising the temperature of water interferes with hydrogen bonding because it leads to vibrations and rotations of the molecules that make it more difficult for the molecules to orient themselves to maximize hydrogen bonding. Higher temperature leads to increasing disruption of the hydrogen bonding.
So we talked about 3 different chemical bonds, okay? The first one was ionic bond. Good example was sodium chloride. The second bond was covalent bond, okay? Within covalent, there could be 2 different types. One is polar covalent bond. Okay, polar means the electronegativity is shifted to one side, okay? The second one is non-polar covalent bond. Okay, good example was methane gas, okay, which shared electron evenly, okay? The polar covalent bond creates the delta plus and delta minus, okay? Because that delta plus and delta minus can, attract to each other. The third type of hydrogen bond is possible, okay? Among 3, which one is the strongest bond? Covalent bond. Which is the weakest one? Hydrogen bond, okay? And the hydrogen bond is important for water characteristics. Okay, good example is the specific heat. Okay, specific heat is defined the energy that you have to put in to raise the temperature 1 degree in Celsius. Okay, is specific heat. 우리나라 말은 뭘? 비열. Okay, so in water specific heat is higher than any other. Okay, because if you have to put energy to break all the the hydrogen bond. Okay, that's what you have to put. That's why you have to put more energy to water. Okay, that translates into our body has lots of water. Okay, that keeps very, very constant condition inside. What do we call it? We call it homeostasis. Okay, one of the characteristics of life, which we did last week. Okay, which is we want to keep our internal condition as stable as possible. Okay, so our body temperature remains 37 or 36.5 Celsius. Okay, that's because it has lots of water. Okay, we can skip this one. So water and life. Okay, water is very important for our life. Okay, water has several qualities that have strongly affected life on Earth. Okay, so there are three terms, easily confused, but you don't have to. You should not confuse. Okay, solution. Okay, solution, solute, solvent. Okay, it's like you put the coffee mix into hot water. Okay, that coffee is solution. Hot water is solvent. The powder that you put it in is solute. Okay, you got it? Don't get confused. Okay, so water is also a good solvent. Okay, why? Water molecule is polarized. Okay, there is a example like this. If you put sodium chloride into water, what happens is water molecule kind of attract that ions and they go around and wrap around. Okay, so water is very good solvent. Okay. Okay, what else? Another one is the ice is lighter than water. Okay, it's the same molecule, right? But its state is different. Liquid state and solid state. Okay, somehow solid state is lighter than liquid. It's important because that's why the ice covers the top of the water. Okay, and then keep the temperature water is constant below the ice. That's why this fish can survive during the winter. Even though the ice can cover the top, the bottom water can remain above the freezing point. Okay, that's another important point of water molecule. Okay, what else? Okay, so next question is, if you go to California, there are lots of redwoods in northern part of California. Redwoods is very, very tall trees, as high as 100 meters high. Okay, it's very, very high. So the question is, how on earth this tree can pump the water to all the way top, the leaves on the top, they also require water. So how can you pump this water all the way up? So you live in apartments, right? Which floor? Anybody lives in above 30th floor? Anybody lives in Tower Palace? I say, so our apartment is 7th floor, but still, what do you do in your apartment? You keep the water tank all the way top, and you pump it, and then you use it, right? What about the trees? Okay, trees, they don't have pump. How can you pump all this water all the way top as high as 100 meters? Okay, that's also can be explained by characteristics of water molecule. Okay, one of them is cohesion. Okay, in other words, water molecule can stick to each other. We saw it because little hydrogen bonds, okay, can pull together. Okay, so what happens is The roots absorb water, but water is connected all the way to the leaf. Okay? They are connected, but they cannot push up. What they have to do? The leaf has to breathe, and also at the same time, they can evaporate water. Okay? So water molecule goes out and pulls the next water molecules. That pulls all the water molecule from the root to the top. Okay? That's how can, so in other words, tree needs a lot of more water than actually they use, okay? Because they can evaporate all the waters, okay? So there are two more terminologies coming. One is hydrophobic, the other one is hydrophilic. Hydrophobic means water hating. They don't like water. Hydrophilic means water liking, okay? That has to do with polarity. If the molecule is polarized, they will get along with water, so they become hydrophilic. Okay? If they are non-polar, right, hydrocarbons, and those are hydrophobic. It will be important for the next chapter. Okay? So hydrophilic and hydrophobic. Okay? Good example is oil is hydrophobic. They don't mix with water. Why? If you go into the oil, it's all hydrocarbon. In other words, carbon and hydrogen. They are all non-polar. Okay? So they don't mix with water molecule. Okay? Up to this point, a few more. This is last section of this chapter, the acid and base. And then we'll have 10-minute break. Okay? So all right, acid and base, we probably know, right? You guys should know from Department of Chemistry. So acid is defined as the molecule that can donate H+, hydrogen ion. Okay, one more time. Acid is defined as what molecule that can easily donate H+. The opposite is for base. Base can easily accept H+. Okay. So strong acid is HCl, hydrochloride, and strong base is NaOH. Okay. If you mix, they'll become neutral. Okay. The textbook doesn't say anything about this, but there is a buffer solution. Okay. Buffer is kind of absorb the difference in pH. In other words, buffer is made of what? Strong acid and strong base? Nope. Buffer is made of weak acid and weak base. Okay, it's not in the textbook, but it's good to know, right? So pH is measure of acidity or, right? So scale goes from 0 to 14, okay? So this is the common things, the pH of, things that we everyday use or drink. Your black coffee is around pH 5, which is a little bit acidic. In other words, if it is 0, pH 0 is very acidic. pH 14 is very strong base. Okay? If it is around 7, it's neutral. Okay, water or our body fluid. Okay? Your coffee is a little bit acid. If you drink wine, it's about pH 3. It's kind of acid. What is basic one? If you, the detergent, bleach, when you use in the your laundry, this is very basic. So this pH is log scale of concentration of hydrogen ion. Okay, so if pH is one difference, pH 9 and 10, it's tenfold difference. Okay, do you understand? No? Yes? No? Scale is log scale, base 10 scale. So it's one difference is tenfold difference in acidity or, okay? So a substance with pH 9 is 10 times as basic as substance as pH 8. Okay? All right. So living things function best in near neutral pH. We'll go back. In life, it's good to balance around neutral, but some exceptions. Your stomach acid is very acidic, okay, and so on. So that is for chapter 2. We'll have 10-minute break, and then we'll start chapter 3. So something like across water loving. What was the word? Hydrophilic. Good. Any substance that accept hydrogen ion in aqueous solution. Accept hydrogen ion. Base. Good. Water fearing. Hydrophobic. Okay. A difference in electrical charge. Polarity? Or, yeah, polarity. Good. A charged atom? Ion. Not that bad, right? Chapter 2, and I'll give you chapter 3 at the end, but I don't have enough of it. So, okay, and then we'll go through one more time for those who missed the last class, okay? So this is syllabus. You can also download from online, okay, class. Last week was the first week. We covered chapter 1. Today is the second week. We'll go through chapter 2 and 3 and so on. So midterm exam is October 15th, okay? We'll cover from chapter 1 to chapter 10, okay? So each class will go through 2 chapters, okay? If the weather is nice, we'll go sometimes outside. We can have class outside. Some classes I can provide you, not lunch, but snack. Okay, and so on. Okay, so the class will be evaluated by 40% of midterm exam and 40% of final exam. Exams are mostly multiple choice, all English. Okay, I might ask a kind of short answer like, what is the unit of life? Cell, or something like that, okay? And attendance is 10%, and your homework is 10%. Any questions? The textbook, if you can get this 5th edition of A Guide to Natural World, 5th edition looks like this. This is better, but bookstore, they don't have it, so they have 4th edition. The difference is they don't have the summary and multiple choice questions. So I uploaded the summary and multiple choice practice question online, so you can practice. Okay. Any questions about the class? 아, 답은 어떻게 하냐고? 그래요. 5장 책에는 답이 있는데. Yeah, we can have, we can solve, we can go through some of the questions. You go through, by yourself, and then you can ask questions if you're not sure. And there will be review session before midterm and before the final. You can ask, and I'll go through some of the important questions with you. Okay? Any other questions? 숙제. The first week homework you can hand in next week. Okay, you can download and you solve it, hand in. So at the end, I'll count how many homework you have submitted. Okay? Any other questions? 또 우리말로. Okay? All right. So let's go to chapter 3. Now it's getting a little bit more complicated than chapter 2. Okay? It's called Life's Components. We'll think about a few things in our body or what we eat, okay, and some stuff in life. Okay, so carbon's place in living world, okay. So carbon is very, very important. Okay, why? Because carbon has 4 electrons in outer shell, the second shell. Okay, so it can have many bonds, as many as 4. Okay, we saw it at methane gas. It can have 4 covalent bonds. Okay, so if you think about the Lego when you play, okay, if it is you can put many things, you can use a lot, right? It's useful. It's the same thing. The carbon is, multiplayer in life, molecules. Okay, that's the way it is. Okay. So complexity of living things is facilitated by carbon's linkage capacity. Carbon has great bonding capacity due to its structure. Okay, that's the same thing. Okay, it's going to a little bit more. We have to remember a few things. I know biology is a very interesting topic, but you have to remember things. Okay, that's the tough one, right? So let's go through. It's called functional group. You will see many of these structures over and over again. So why not just go through and try to remember a little bit. Okay, it's called functional group. Okay, this group can confer some special characters to the molecule. Okay, what are they? It's called carboxyl group. Carboxyl group. You can put carboxyl group. What is it? It's a COOH. So the structure goes like this. And you will find this functional group in fatty acids or amino acids. What is the common word? Acid. What was the definition of acid? It will lose. It will donate H plus from here. Okay? So eventually it will go COO minus. Okay? That's what it's important. Carboxyl group. Okay? Hydroxyl group, it's easy, OH. You can find this thing, alcohols and carbohydrates. Okay? Alcohols, so mostly if you have this structure, they will have name as ol, methanol, ethanol, propanol. Okay? They all have this OH group. Okay? The third one is called amine group. Amine, NH2. Okay? So amino acid, you can find this one. In neutral pH, what we'll see is usually they will exist as NH2 plus. In other words, they can accept one more plus. Okay? So just remember amine group. Okay? The fourth group, okay, it's called phosphate group. Okay, phosphate, phosphorus and 4 oxygen group, PO4 minus. Okay, so it has charge, and you will see this thing a lot in DNA and ATP. It's okay, you don't know what DNA is or what the ATP is at this point, but we'll learn about it. Okay, in that case, we have to know phosphate group. Okay, the 4 functional group, hydroxyl group, carboxyl group, amine group, phosphate group. Is it okay? You can handle this? Good, good. Okay, those are the functional groups you will see a lot in biomolecules. Okay? So functional groups often impart an electrical charge or polarity onto molecules, thus affecting their bonding capacity. What is the common function of this? If you add this functional group, that will give you charge into the molecule. Okay, so that will make this molecule polar. Okay, so it will come back again and again. We'll see. All right, so we'll go through some of the components. Okay, for life. Okay, the first one is carbohydrate. It's one of the nutrients that we have to take. What do you call it? 탄수화물. Okay, it's carbohydrate. Okay, carbohydrates are formed from the building blocks of monomer of simple sugar. The first characteristic of carbohydrate is it has a building block. What do you mean by building block? You start with small molecule, you put together, and you can make a big one. Okay, so you start with smaller, we call it monomer. It has one monomer. You start put together, you become polymer, many. Okay, what is the starting material? It's simple sugar. Glucose is the building block of carbohydrate. Okay, so there are different names, polymers or polysaccharides. Saccharide means sugar. Okay, so polysaccharides means you have put lots of sugar together. Okay, that's polysaccharide. So what is the characteristic of carbohydrate? You start with small one, building block, you put together, you make a long one. Okay, that's carbohydrate. We have to go through 4 different types of carbohydrate. They have their names: starch, glycogen, cellulose, chitin. Okay, starch we know in Korean it's 뭐지? 전분, 녹말. Okay, starch. You don't have to know what it is. We'll go through it. Glycogen, glycogen. Glycogen. Okay. And cellulose. Chitin, chitin. Okay. So starch. So if you know 감자전, right? You grind a potato and you make a pancake. Okay, that sweet stuff, white stuff comes out of potato. That's the starch. Okay, glycogen. Glycogen, it's a little difficult. So this is the storage of glucose in your liver. Okay, we'll come back. Cellulose, if you know what the celery is, the vegetable, okay, you have lots of this cellulose. Okay, you eat, it's good for you to eat, but you cannot digest. So what happened? It will go out. Okay, then why do we eat? It's important to have something to go out, right? That's why you have to eat salad. Okay, during the Korean War, the U.S. soldiers from, they helped Korea. Okay, they were surprised to see how Korean soldiers have the big boo-boo. In other words, the amount of boo-boo, in other words, because all Korean soldiers ate rice and kimchi. That's why they have lots of cellulose they cannot digest. They will go out. Okay? But if you eat meat, there's nothing to waste. It will all used up and you have little boo-boo coming out, which is not good for you. We'll come back. Okay? Chitin. Okay, chitin, sometimes chitin. Do you like lobsters or crab? They have red shell. Okay? That's made of chitin. Okay, if you think about insect, they have very hard shell, right? That's made of chitin. Okay? So we studied all of them. So starch, okay? Potato. What is the meaning of this starch? Okay? It's the storage of sugar in plant. Okay? Plant, they make sugar by photosynthesis. Okay? They use the sunlight, they make sugar. Okay? Sometimes they store in fruits, that's why it's sweet. But sometimes they store this glucose in the form of starch. Okay? So the function of starch is storage in plant. What is storage in animal? It's called glycogen. Glycogen in your liver or in your muscle. Okay, that's the function is storage of sugar. Okay, what about cellulose? It's structural thing. Okay, the plant is straight up because they have lots of cellulose. They give physical support. Okay, same thing. Chitin is structural support for insects or crabs, lobsters. Okay, hard shell. Okay, so this carbohydrate. Okay, the character number 1 is start from small monomer, small building block, which is glucose. Okay, each little the hexagon is glucose. Okay, and they can make big long one. Okay, polymers, polysaccharides. There are 4 types we have to remember: starch, glycogen, cellulose, chitin. 2 of them are for storage of energy in plants, in animal cells. Okay, 2 of them for structure support, cellulose, chitin. Okay, not that bad, right? Yes, questions? Why do you have, yes?
What's the difference between the cellulose and chitin? They look very similar.
They look similar, right? I don't know, but but cellulose. So plant and insect, they have their special enzymes. They can make this building these polymers, right? So the bond is different, or somehow plant they can make their own support. Okay, chitin is probably more hard than cellulose. I can just say, but both of them is mechanical support for plants and insects. Okay, yeah, I should know about this, but I don't know. Okay, other questions? Good question. Okay, but they look similar, but they have little branch, right? So their structure should be different. Okay. Okay. More questions? No. Right. Starch is the nutrient storage form of carbohydrate in plants. We'll go through. Glycogen is nutrient storage form of carbohydrate in animals. Usually they store in your liver or in your muscle. So even if you skip your lunch like today, your liver will provide sugar, okay, or muscle, okay. Cellulose is a rigid structured carbohydrate found in cell walls of many plants, okay. That's why you have to eat salad, okay. Chitin is tough carbohydrate that forms external skeleton of arthropod, a little difficult word. It's crabby or lobster. Okay. External skeleton. Skeleton means bones. Okay, bones. Outside skeleton of arthropod. Okay. Now, second one is lipid. Okay, this is interesting material. Okay, it also something has to do with diet. Okay, so go through the, okay. The first character was carbohydrate was they had small building block, right? Like sugar, simple sugar, glucose. You can put together, you can make a long one. But lipid, no, they don't have it, okay? They don't have building block. So what do? You have to remember 4 different types of lipid. Let's start with the first one, okay? So defining characteristic of all lipid is they do not resolve in water. They don't like water. That's all character they would know, define as a lipid, okay? The first one is called, second one is, no one structural element is common to all lipids. They will tell you about 4 different types of lipids, but they don't have common structure, okay? It depends on their own, okay? The first one is called triglyceride. Difficult name, right? Sometimes we call 중성지방, okay? Triglyceride. Tri means something has 3, right? Triglyceride. So this is the structure of triglyceride. Okay. So now you follow. You start with molecule called glycerol. Okay, glycerol. You can find this glycerol in your makeup. It's something sticky, right? The solution is glycerol. Okay. Glycerol has 3 carbon and it has name O. So what does it have? Yeah, it has name O. Ethanol, methanol, glycerol. What does it have? OH, hydroxyl group. 1, 2, 3 hydroxyl group. Okay. This hydroxyl group is connected to called fatty acid. Fatty acid, what is it? It's acid, right? So at the end, what does it have it? Carboxyl group, COOH. Do you remember? Functional, you can go back to your book, check carboxyl group. It's important to remember those functional groups. I told you it will come again and again. Okay? So it has 3 fatty acid connected to 1 molecule of glycerol. Now it's getting hard, right? But that's the triglyceride. 3 fatty acid is connected to glycerol. This is neutral fat. We call it lipid, the most common form of lipid. If you go to 왕십리 and you're eating 삼겹살 tonight, okay? So you burn this thing and then there's liquid coming out of the 삼겹살. That's this one, okay? If you cool it, what would happen? It solidify, okay? So mostly it's called animal fat. So we talk about, animal fat is bad and saturated fat is bad, unsaturated fat is good, and then there's omega-3 fatty acid is good. It's confusing, right? Today you can make all sense out of it, okay, if you understand the structure of lipid. Okay, let's start. Okay, so this is structure of triglyceride or triglyceride. So 3 fatty acids attached to 1 molecule of glycerol. Okay, and then now, this is 4th edition, right? Okay, 4th edition, you are looking at page 48. Okay, 5th edition, you're looking at page 49 and 50 and 51. Okay, so the question is, which fatty acid is good for us and which fatty acid is bad for us? Okay, this is fatty acid. What do we see? You see lots of carbon and hydrogen. Okay, if it is a straight, okay, it means it has all single bonds, 1 line. Okay, it's called saturated. 포화 지방산. Saturated means 포화. There's no room for more hydrogen. No more hydrogen. Okay, it's saturated. Okay, 포화. Okay, so we have 3 saturated fatty acids. Okay, and we draw it as straight lines, as straight as an arrow. Okay, so this is mostly coming from 삼겹살, animal fat. Why? I told you you burn this 삼겹살. Okay, there's liquid coming out. That's the fat. But if you cool it enough, what happens? They'll solidify the white stuff. Okay, so why? Because they are straight as an arrow. Okay, they can line up very well. Okay, at room temperature, they're straight up and they will solidify. Okay, and if you think about, you eat lots of 삼겹살, they go through, in this state, they go through your blood, and at room temperature, they started to solidify in your heart. What happened? you will have heart attack. Okay? It will block your blood vessel. Okay? Think about now, we think about olive oil or some other vegetable oil. We call it unsaturated fatty acid. Okay? Unsaturated means they have double bond somewhere here. Okay? Double bond between here because they're missing hydrogen here. Okay? That means you can add more hydrogen. That's why they are still unsaturated. 불포화 지방산. Okay? If you look at their structure somewhere in the textbook, they are kinked. In other words, they are not straight. They're kinked like this. Unsaturated fatty acid will like this. Okay? So because of their kinked, they cannot line up a little bit. They cannot line up well enough. Okay? So what happened? At room temperature, they're liquid. Think about olive oil. Think about sesame oil. They're all liquid in room temperature. That's why it's better for you than saturated fatty acid. Got it? So saturated fatty acid is animal fat in which is solidified during at room temperature. That's why it's bad for us. Okay? What about omega-3 fatty acid? The new version, 5th edition, has a special section about omega. What is omega? Chemistry. What is omega-3 in this hydrocarbon? Do you know the car name Atos? Yeah. Where those names come from? A to Z. Okay? So A is alpha, Z is omega. Okay? So omega is the last carbon. Okay? Omega-3 means third position from the last carbon. Okay? Omega-3 fatty acid means the third position has double bond there. Okay? So in other words, it's also unsaturated fatty acid. You can find in fish. Okay? 등푸른 생선에서. Okay? So they're also kinked. Okay? Although they are coming from animal, fish, they have unsaturated fatty acid, which is good for you. I don't know how good that it will be. But omega-3, now you understand what omega-3 fatty acid and then saturated fatty acid and then, what was it? Unsaturated fatty acid. The last one, more complicated one is trans fat. You heard about it, right? Trans fatty acid. What is trans fatty acid? Again, chemistry department. Okay, usually this double bond is cis formation. Cis formation is something like this on the same side. Okay. Transformation is, oops, 어떻게 그려야 되지? The opposite side. Okay. When there's double bond, the rest of them can be cis formation or transformation. Okay? So briefly, trans fat is originally from unsaturated fatty acid. But in chemical process, they can put hydrogen atom to kind of saturate. Okay? So it's processed material and it gives you a little bit tasty. So some of the potato chips and some cookies, they use trans fatty acid, which is not good for you. Okay? Although trans fatty acid will give you straight, they will give you straight formation. Okay? So what happened is trans fatty acid, they solidify at room temperature. So it's easy to keep those fatty acids in storage. That's why manufacturers manufacturers are using trans fatty acid, which is easy to handle but bad for your health. Got it? So we talked about 4 different types of fatty acid. The best one, they say good for you, is omega-3 fatty acid, which is unsaturated, which is kinked, okay, although they're coming from animal, fish, okay. Second one is olive oil, which is unsaturated fatty acid, because they are kinked. They don't line up very well. That's why they're liquid at room temperature. The third one is saturated fatty acid, 삼겹살. Okay, they're straight, no double bonds, straight. They solidified at room temperature. They're coming from animal, but still, occasionally, if you eat, it's okay, right? The worst one was trans fatty acid. Okay, all right, we'll go. We talked about one type of lipid, okay, which was, what was the name of it? Triglyceride. Okay, it starts with one glycerol molecule attached to 3 fatty acids. Okay, depends on what kind of fatty acid you're attached to. Some of them are good for you, some of them bad for you. Okay. Second type of lipid is called steroid. Okay, sounds familiar, right? Some of the athletics used to take steroid to build up like this. Okay, but it's part of our hormone, also steroid hormone. Okay, what is the characteristic of this steroid? They have structural characteristic. They always have this 4 ring structure. Okay, ring structure. Okay, so some of them, testosterone, estrogen, cholesterol, they are all steroid type of lipid. Okay, so some of them are sex hormone, for male testosterone, female estrogen, cholesterol, if you have too much, bad, but you have to have cholesterol. Okay, so these are type of steroid lipid. Okay, so we talked about 2 types of lipid. What is it? Triglyceride and steroid. Are you okay? Are you following? Okay, good. Now the third one is very similar to the first one, triglyceride. Going back to think about what is triglyceride. Yes. 왜 지방이라고 정의하느냐고? So why do we put steroid into lipid? Because they don't like water. The only common character of lipid is they don't like water. They don't mix well with water. That's the only definition that we have. Although they have all different structures. Okay? Right. Because in our body, steroid hormone can pass through the membrane easily. We'll come back. Okay? That's very important character. 또 질문. Good question. Okay? So again, the third type is phospholipid. Phospho. We go back to functional group. The fourth one was, what was it? Phosphate. Remember, PO4 minus, right? Phosphorus in the middle and has oxygen. Okay, that's phosphate group. Now something with phosphate group. So what is the structure of phospholipid? You start with, think about going back, triglyceride. You start with glycerol molecule, okay, and has 3 fatty acids attached, right? That was triglyceride. In this case, only 2 fatty acids attached. So there's one left on OH of glycerol, right? That OH is attached to phosphate group. Okay, so it's very similar to triglyceride, but slightly different. Okay, it has only 2 fatty acids, and then phosphate group is attached, the third position. Why is it important? It's important for membrane, to make membrane. What is membrane? The boundary of the cell. Okay, cell membrane. Okay, so by putting this phosphate group in here, it will give polarity. It will give polar. It will give minus charge. Okay, so in this case, this head group is hydrophilic, polar. This tail group is all carbon and hydrogen, right? So they are non-polar. Okay, so we call it non-polar tails and polar head, charged head. So why is it important? If you put this thing into the water or oil phase, what will happen is head is hydrophilic, so they go to water, and tail is hydrophobic, they go to the oil. Okay, so because of this character, we'll have membrane structure, which is next week. Okay, we'll go through there. So that was the third. There was the third type of lipid. What is it? Called phospholipid. 너무 시간 많이 끌었나? 그런 것 같은데. All right, so we went through 3 lipids, right? What is it? Triglyceride, steroid, phospholipid. The fourth one you don't have to worry about much. It's called wax. Wax. If you go to somewhere, there is a wax museum. 밀랍 인형 만들어 놓은 museum. It's called wax museum. Or sometimes you go to a grocery store. The apples are shining so much. You wonder why, right? They put wax on top of it, so not to dry. Okay. Some of the trees, their leaves are shining, right? Those are this is a leaf of plant. Okay. They secrete this wax to protect them, okay, to get from losing water, okay. It's the same like you're putting your makeup on your face because it keeps moisture, okay, same thing. So the wax, don't worry about the structure. Now, problem. What time is it? 5 more minutes, okay. Yeah. Next one is protein, okay? So we did carbohydrate, lipid, protein. Those are 3 essential nutrients that we have to take, right? So proteins, 단백질, proteins, okay? So proteins are an extremely diverse group of biological molecules composed of monomer. What is the name of monomer? It is consists of amino acid. Yes, amino acid. The question is, why do we call it amino acid? Because it has amine group as a functional group. At the same time, it has carboxyl group. That's why we call it acid. Okay, so the structure, so we call it amino acid. This is one amino acid. Okay, there's a center carbon, and then on the left, what do you call it? This is amine group. Okay, on the left, it's a COOH, carboxyl group. Carboxyl group will donate this H+, so it'll become acid. That's why we call it amino acid. Okay, there are 20 different amino acids. Okay, building block. So you start with 20 different amino acids. You can put together, you can have so many different combination of proteins. Okay, that's why protein is so diverse. Okay, what is the function of proteins? It can be enzyme, it can be hormone, it can do a lot of things in our structure. Your appearance is mostly made up of protein. Your hair, your face, everything is made up of protein. Okay? So, in order to make protein, this amino acid has to be strung together. Okay? So what do you call it? OH and H come out as water, a condensation reaction. We call it peptide bond. There's another bond. It's same as covalent bond, but it has a special name. We call it peptide bond because through this bond, it will form a peptide. Okay, amino acid you put together and it become polypeptide. Many amino acids put together. Okay, so like this. Okay, there are 20 different amino acids. Does it have any list of it? Doesn't have it. Okay, if you're life science major, I'll ask you to remember all 20, but since you're not, I'll not ask you to remember. But it has 3-letter name and 1 alphabet name, but there are 20 different types of amino acids. Okay. 여기까지만 할게요. Up to one more topic. Okay. So protein is consists of what? Amino acid. The building block of protein is amino acid. Now, you're making from amino acid to protein. Protein has many functions, okay? But its structure is very, very important for their function. Good example is if you're cooking fried egg, okay? Eggs, the yolk, and then there's white stuff, right? And if you once fry it, what happened? It becomes turn white, right? And if your protein is changed their structure, you cannot go back to original one. You cannot put fried egg into the refrigerator. They cannot go back to eggs, okay? Because protein structure is very, very important. Once you break the structure, you lose the activity, okay? So there are 4 levels of structure in protein, okay? Primary structure, secondary structure, tertiary structure, quaternary structure. 1차, 2차, 3차, 4차 구조 단백질. Okay. What do you mean by first a primary structure? It means what amino acids comes in order. What amino acid is next? That determines the protein structure. Okay. In other words, which building block you use. Okay. That's the primary structure. Secondary structure, there are particular structure called alpha helix, random coil, and beta pleated sheet. I always have problem with pronouncing this one. Don't speak it too fast. That's not good. Okay? So there are 3 particular secondary structure, motif. Okay? And tertiary structure is 3-dimensional, the final structure of one polypeptide, one string of amino acid. Then what is quaternary? Okay, quaternary means it consists of more than one polypeptide. Okay, good example is your hemoglobin carries oxygen. It consists of 4 globin. Okay, 4 different the 4 polypeptides. It consists of big one. Okay, we call it quaternary structure. Okay. Okay, I have to stop here. I didn't finish chapter 3, but I have some homework for chapter 3. If you don't have it, go to online. So we didn't go through DNA and RNA, so we'll start from nucleic acid next week. Any questions? One more time, you can go into Easy Hub, try to find online class. You can find this class, the 생명과학입문. You might have to read in Korean, or you can go into English version. And if you go to 학습 자료, okay, if you click it, I uploaded all the PowerPoint, your homework, and then summary files. Okay, so you print out quiz, crossword puzzle. You put your name, ID number, solve it, and hand in next week. Any questions? No? So far, so good. So I'll see you next week. Okay?